Welcome to Exploring Python's list data type with examples. My name is Joseph, and I'll be your navigator as together we map the terrain of the Python list. Lists are one of the most versatile containers in Python. Need to store heterogeneous data? Lists can handle that. How about maintaining a dynamic, growing and shrinking sequence of numbers? A list has you covered. Like a good Swiss Army knife, they're an essential tool in your toolkit. But also like a Swiss Army knife, there's probably some features that you're overlooking and maybe even misusing. Like that weird plastic thing that's apparently a toothpick, or the pointy piece with a hole in it. That's something I'm told is called an awl. My point is, in this course, you're going to take a deep look at the key features of the Python list, ensuring you can take advantage of its full potential throughout your Python programs. You'll start by learning the ways you can create new lists in Python, then a discussion on retrieving elements from an existing list, how to use Python operators with lists, like the plus and star operators, how to copy, update, grow, and shrink existing lists, as well as how to sort, reverse, and traverse existing lists. And finally, how to avoid common errors made when handling lists. It'll help if you're fairly comfortable with core Python concepts, like variables, functions and methods, for loops, and built-in data types. But don't worry, I'll also be explaining things as we go along. For now, if you're feeling like a refresher on Python's data types, check out Basic Data Types in Python, a quick exploration. Okay, before we get to coding, the next lesson will be a brief orientation where we'll answer the question, what is a Python list? The list data type in Python is a built-in data type, meaning it's available everywhere in your code without using imports. And more specifically, it's a sequence data type, making it a kind of container that holds multiple elements. And it's characterized by having its items enclosed in square brackets. Lists are also one of the most versatile containers in Python, due to some of the particular properties of lists. Some of these properties include being ordered, meaning their elements are arranged sequentially based on insertion order, zero-based, in that they support accessing those sequential elements by index, with indices starting at 0. They're mutable, meaning list objects can be mutated in place. Their elements can be changed or moved around. This makes them flexible, but it also means that a list can't be used as a dictionary key or as a value in a Python set, because the list's mutability also makes it what's known as unhashable. Lists are dynamic, capable of growing and shrinking dynamically. And because lists are heterogeneous containers, they can be populated with items of differing types, including other lists, which makes them nestable. You can make lists of lists and even use lists to emulate matrices. Lists are iterable. They allow you to traverse their elements using loops and comprehensions. They're sliceable, meaning they support Python's slice notation to extract a series of elements. And lastly, they're combinable. They support concatenation operations, letting you combine multiple lists together. All right, that may seem like a lot, but you don't need to memorize this. We'll be examining all of these characteristics in depth throughout the rest of this course. So follow me to the next lesson, where you'll begin by looking at the primary techniques for creating new lists. Let's explore the 3 main ways you can create a new list. You can use list literals, where you define a list as a sequence of comma-separated values enclosed with square brackets. This has the syntax of mylist equals, opening bracket, item 0, item 1, 3 dots to indicate some items in the middle, and ending in item n and a closing bracket. Great for creating a list based on hard-coded values or specific variables. Then there's the list constructor, which can be called like a function. It uses the syntax mylist equals calling list and passing in an iterable argument. The word iterable is in brackets here to indicate that it's actually optional. If you call list with no arguments at all, it returns an empty list. Perfect for creating a list based on another existing variable. And then a very Pythonic way of creating a list, the list comprehension, sometimes called a list comp for short. It may look similar to a literal, but there's a lot more going on there. The syntax is mylist equals, and then all in square brackets, expression for element in iterable. The list comprehension iterates over some iterable and builds a new list based on the expression provided. You can add all sorts of logic to a comprehension, making it a very versatile and concise way to create a list. Now let's go to the REPL and see these techniques in action. Here in the REPL now, let's create some lists, starting with list literals. How about a list of your favorite fruits? Fruits equals open bracket, the strings pineapple, coconut, lime, close bracket. Examine fruits and pineapple, coconut, lime, just as written. You could make a list of Python built-ins. Functions equals open bracket, print, len, range, type, close bracket. Examine functions, and you see the string representations of each item. And yep, range and type are technically classes, not functions. And of course, lists are heterogeneous, so you're free to make a list of completely different types as well. Whatever random things come to mind. Random things equals open bracket, the integer 1701, the Python built-in type, the string galaxy, and a tuple literal containing the strings will and data. You can use type to type check this and make sure that it is a list. Yep, still a valid list. Though this kind of heterogeneous collection is more common in the form of a database record, and for efficiency reasons, it's typically better to represent those using tuples. Sometimes you just want an empty list that will be filled programmatically later. Empty equals a pair of empty square brackets. And empty is an empty list. This is equivalent to calling the list constructor with no arguments. List with a pair of empty parentheses also returns an empty list. And speaking of the list constructor, it can also be used to turn an existing iterable into a list. But be careful, it will not create a list from multiple arguments. So if you try calling list and passing in the integers 0 through 4, you get a type error. List expected at most 1 argument and got 5. What you need to do instead is use a valid iterable. Call list passing in a tuple literal holding the integers 0, 1, 2, 3, and 4, and it returns a list with the same elements. Lists can also consume set literals, passing the strings pineapple, coconut, and lime as a set literal to the list constructor this time. You get the list lime, coconut, pineapple. And it's important to note that sets are unordered, so the result won't necessarily have the same ordering that you used to create the set. Another tricky one is passing a string, since they are also iterable. If you pass the string enterprise to the list constructor breaks down the string into its individual characters, resulting in a list of letters. If this behavior catches you off guard, you can end up with some pretty subtle bugs. Another thing, because the list constructor consumes iterables, it's great for creating lists out of objects that you might need to iterate over. You'll see more on iteration in future lessons, but for now, here's how you can create a list of the integers 0 through 9 by using a range object. Call range with the argument 10 and pass it to the list constructor. And there's your list of numbers. Lastly, let's look at comprehensions. At minimum, you need an expression and an iterable. Put simply, an expression is anything that results in some value when evaluated. You can see this by using a list comprehension to create a list of zeros. Open bracket, 0 for underscore in range 10, close bracket. And you use an underscore here to show that the elements retrieved from the iterable go unused. For each of the 10 elements in the range object, you add a 0 to the list, and so you get a list of 10 zeros. For a more typical example, you would normally use the value in the iterator in the expression, like this. Open bracket, number, star, star, 2, for number in range 111, close bracket. The double star here is the exponentiation operator and raises number to the power of 2. Because at each step of the loop, number holds a value retrieved from the iterable, this is done for all numbers from 1 to 11, not including 11. So your result? The squares of the numbers 1 through 10. And this is just the tip of the iceberg on comprehensions. If you want to dive a bit deeper, have a look at when to use a list comprehension in Python. Now you know about creating lists. Next up, actually accessing the elements inside them. One of the benefits of lists is that due to their sequential structure, retrieving items by index is a highly efficient operation. So to access elements from an existing list, you can use a pair of square brackets. Individual elements can be retrieved by their zero-based index, using the syntax mylist with the integer index value in square brackets. Alternatively, you can retrieve multiple elements at once using a Python slice. This always returns a new list, and the syntax is mylist, and in brackets, start, stop, step, where start indicates the first index value to retrieve, stop is the non-inclusive endpoint, and step is the gap between each element retrieved. Start, stop, and step are all optional. This can make slices a little hard to read at first, but you'll find it's an incredibly useful technique. Now let's practice in the REPL. Start by creating a list of 5 strings. In this case, 5 popular programming languages. Languages equals a list of the strings Python, TypeScript, C++, Go, and Rust. Using square brackets, access the item at index 0, and languages at index 0 gives us the first element, Python. To go to the other end of the list, try languages at index 4, which gives us the 5th element, Rust. And if you go a bit too far and try to access languages at index 5, you'll get an index error, list index out of range. You'll get this error anytime you try to directly access an index that does not exist, so be careful. You can also access indices in reverse, using negative indexing. I like to think about it like walking backwards from the first element, index 0. So index -1 returns the last element in the list, and so on. Languages at -1 returns Rust, the last element in the list. Languages at index -2 returns the second last, Go, and on it goes, ending in index -5. Languages at index -5, which returns the first element of the list, Python, the equivalent of accessing index 0. Positive indexing is good for when you know where something is relative to the start of a list, and negative indexing is good for when you want to get an item relative to the end of the list. I'll clear the screen for the next example. And to explore slicing, start with a list of integers from 0 to 9 and call it digits. If you want to save some typing, feel free to use the range trick that we saw in the last lesson. To get the first 3 values, use square brackets with the slice :3. Digits at :3. Remember, the syntax for a slice is start: stop: step, all in brackets. Omitting the start value defaults to starting at the beginning of the list, and omitting the step value defaults to a step size of 1. Setting stop as 3 tells Python to go as far as index 3, but not include it. And so this returns a list with the first 3 values of digits, 0, 1, and 2. Conversely, you can use the slice digits at 3: omitting stop and step. When stop is omitted, the slice continues to the end of the list, including the last value. So this returns a new list starting with the item at index 3, including all subsequent values. To get the 4 middle elements, try digits at the slice 3:7, which returns the list 3, 4, 5, and 6. Reverse indexing works as well. To get the last 3 digits, you can slice starting from index -3, digits at -3: and the result is 7, 8, and 9. And if you want to include step, you can grab every other element in the list by using the slice ::2. This works because, by default, the slice will start at the beginning and run to the end. Because of the step size of 2, the result is a list of even numbers from 0 to 8. Can you think of how you might change this a bit to get odd numbers instead of even? Feel free to pause and try it out. You can add a starting point of 1 and keep the step size of 2 to retrieve odd numbers. Digits at the slice 1::2, which results in a list of odd numbers from 1 to 9. Another thing to note about slices, if your starter endpoints are beyond the valid indices of the list, you won't actually get an error. So if you try slicing from the start to 11, for example, digits at the slice :11, you get all 10 elements of the list, not 11. And if you try to go from -11 onwards, digits -11: the result is the same, all 10 elements of the list. And if you try to slice starting at an invalid positive index, like using the slice digits 11:, the result is simply an empty list. And that was slicing lists, a powerful tool, but not without its quirks, as you've seen. And there's actually another common use of slicing, making a copy of a list. You want to know how? Well, you'll have to watch the next lesson to find out. In this lesson, you'll explore 3 concepts related to copying lists: aliasing, when you assign an existing list to a new value; shallow copying, which copies the references of objects contained in a list; and deep copying, which creates a new list but also copies the elements of the original list. You can create an alias of an existing variable using assignment. This can be done with any variable, not just lists. The syntax is simply new variable equals original variable. But this isn't truly a copying operation. Instead, you're binding a new name to the same underlying object. And this can be tricky when the underlying object is mutable, like a list. And as a result, modifying an alias will end up modifying the original list, and vice versa. To create a proper copy of a list that is a new list object, you can either shallow copy or deep copy. What's the difference? First, you need to understand that in Python, lists store references to the objects they contain. You can think of a list as a list of addresses, pointing to the locations of the objects within. A shallow copy of a list is a new list that contains references to the same objects in the original list. You can create a shallow copy by slicing, a slice with a single colon, omitting start, stop, and step arguments. Or you can use the copy method of lists, or the copy function from the built-in copy module. On the other hand, a deep copy of a list is a new list whose references point to copies of the objects in the original list, making them disconnected from the objects in the original. This makes a big difference, as you'll soon see. You can make deep copies using the deep copy function from the copy module. Okay, time to write some code. You'll need a list to start with, so how about countries this time? Countries equals a list of the strings US, Canada, Hungary, and Austria. Now create an alias of the countries called nations. Nations equals countries. So how can you verify that countries and nations are both names for the same object? You can use the built-in ID function. Each object in memory has a unique identity, so if ID returns the same value for each variable, you know they reference the same object, and you can compare with the equality operator. ID countries equals ID nations. And it returns true, meaning both variables share an underlying object. You can further show this by modifying countries. Using assignment, set countries at index 0 to the string USA. Confirm that countries has changed. Yep, USA instead of US. Now look at nations. And the first value of nations has been updated to USA as well. So aliasing isn't really creating copies in any meaningful sense. Instead, try a shallow copy. You can use one of the techniques mentioned before. Their output will be equivalent, so for this example, I'll just use slicing. Nations equals countries sliced with a colon and no arguments. Now look at nations. Same contents as before. And incidentally, slicing like this works because the default behavior of a slice is to start from the beginning of a list and go to the end, thus returning all the same elements. But are the IDs the same? ID countries equals ID nations returns false, meaning you now have two distinct objects. But recall that this is a shallow copy, meaning the list elements should share identities. You can test this by looking at the IDs of the first element of both lists. ID nations at index 0 equals ID countries at index 0. And this returns true. So while the lists are distinct, the items within are not. But now you can change the elements in one list via assignment, and it won't affect the other. Countries at index 0 equals the string United States. Look at countries, see that it's changed. And look at nations and see it remains as before, USA. The lists themselves remain distinct, and this works fine in many cases. Where you'll want to use deep copy instead is with something like a list of lists. First, I'll clear the screen. Go ahead and import both copy and deep copy from the copy module. From copy, import copy, deep copy. And create a nested list holding 3 lists of integers, 1, 2, 3, 4, 5, 6, and 7, 8, 9. Call it matrix. Use the copy function to create a shallow copy of matrix called shallow, and the deep copy function to create a deep copy of matrix called deep. You can confirm that all 3 are different objects by checking their IDs. ID matrix, ID shallow, ID deep. The values you see here will differ from mine, but what matters is that they're distinct. This shows they are separate objects. Now you compare the IDs of the first element in each version of your matrix. ID matrix at index 0, ID shallow at index 0, and ID deep at index 0. Aha! While matrix and shallow both reference the same object, deep does not. As a final bit of evidence, let's alter the first sublist of matrix using index assignment. set matrix at index 0, 0 to 100, index 0, 1 to 200, and index 0, 2 to 300. Now examine matrix. That first list has been updated as expected. Take a look at shallow. Again, the first list has been updated. Because it is only a shallow copy, it shares its elements with matrix. And now let's look at deep. It remains unchanged, all thanks to deep copying. As you've seen, copying objects in Python can get complex very quickly. If you're interested in learning even more about the nuances of copy operations, head on over to How to Copy Objects in Python, Shallow versus Deep Copying Explained. It's a topic that's especially crucial to understand when dealing with mutable objects like lists. So in this lesson, you saw a couple ways that you can modify a list. Next up, even more.